I appreciate that. So this session is kind of about our journey and how we get lots of data, right? There's a lot of talk about Sky API. There's a lot of talk about Power BI, and everybody needs data. And one of the things that Reporting Express does is that we run reports. We run package reports. We run custom reports. We run thousands of them every night. And we have some security constraints that we place both on ourselves and that our customers have asked for us, and that we don't really need to maintain multiple threat surfaces, right? When we're taking in customer data, if you have a separate database or a data warehouse that's hosted someplace, it becomes a surface that people can attack. And there's all types of other places where data comes in that we just don't want to provide that to other people to look at. So we want to lock that down. So one of the promises we make to our customers is that when we're done running your reports, we're going to remove all of the data we made decisions on. So we have no data warehouses that we run in the background that someone could attack, or no other storage places other than in the reports themselves. So the surface that is presented to the world is your reporting engine. And in our environment, we secure that with the custom services. So we don't actually have user accounts. The customers have user accounts. So it's a shared security model that doesn't multiply the areas that people could steal data from. And we have lots of data, right? So we have lots of customers and lots of data, and we run lots of queries in parallel. And when we do run lots of queries in parallel, one of the most common things we see in our Sky API is this, right? We've got a rate limit exceeded. And the reason the rate limit exceeded is kind of obvious. Blackbaud has correctly placed a rate limit on how much data or how many times you can make a call to their API. We can't just sit there and provide an area where we go and collect thousands and thousands of calls against one location, because they wouldn't be able to provision resources for that. So the resource provisioning is based on the application that you host inside the Sky API and the authentication context for it. And in some cases, you get a couple of calls a second. In some cases, you get up to 8 or 9 calls a second. But if I'm running lots and lots of customers in the background, and I'm running lots and lots of reports, and I need literally tons of data that I'm going to throw away because I need it tomorrow, then we're going to get a lot of contention. So for example, we have to get transaction logs. We have to get transaction detail for FE. If an account or a project is still open in FE, or the period is still open, then you can't really count on the summarization systems inside Sky API to give you a balance. So you have to go back and collect them all. So if you have a customer, and we have several who keep all of their project transactions open for 5 or 6 or 7 years so that they can look at detail, we have to roll back 5 or 6 or 7 years every night to collect all the data so that we can add it up. So that's kind of a normal mathematical problem, but it manifests itself as lots and lots and lots of parallel Sky API calls. And so the problems that we have are, again, we talked about rate limits. There's a concurrency to the rate limits that's applied to the endpoint. That's legitimate. There's nothing we want to do about that. I'd like it to be higher, but we can't, right? There's a limit to the infrastructure that can be applied to it, and rightfully, Blackbaud has to balance that against everybody's usage. There's also, for those of you who are developers and who work with the authentication tokens, they're good for about an hour, and they have to be refreshed. So if you're just running along one request at a time, and you have to refresh your token, it's not that big a deal. But if we have 10 or 15 processes that all of a sudden need to re-authenticate, then you have some collisions that happen there when they all try to do that at the same time. So we need to put some orchestration around that. The other thing that we have is more imposed upon ourselves. The Sky API authentication and authorization is not on a per endpoint basis. So you have an end user that represents the back-end security for the Sky API session. We get that when we authenticate the system and when the user logs in to provide permission to that. But that's the scope of what it is. That user has that permission. We need more granular authorization. We need some reports to be able to call endpoints that get FE data. But other reports that might be running in another location, they only need to be able to get to RE constituents. So that's something that we need to provide externally to that. We also need an audit trail. We promise our customers that if you want to know what we did, whether it be an end user or a process, you can always go look at your audit trail and see exactly what happened. We called this endpoint, we got some records back, we did something with it. That's something that we also don't have visibility to in the Sky API. They do have an audit trail of calls, but I believe it's more for diagnostic purposes than for security auditing. In our case, we need to provide security auditing to our customers so that we can show how we use their data. So these are the problems that we deal with when we're talking about how we want to scale up the Sky API calls. So for our solutions to these, some of them are pretty simple, some of them are pretty complicated. On the authentication side, for every one of our customers, we have a timer that runs. And the timer runs about every 20 minutes, I believe it is, and it keeps the token fresh for query clients. So as we talk about this, let's talk a little bit too about how programmatically you deal with all these things. So let me roll back one slide. These first two, authentication and rate limits, when they feed back to a client, if you're a programmer and you've written a Sky API client, they manifest themselves to you as your client as an error. So we have an error condition. So you get back that 429 error and you have to retry. Or you get back an authentication failure and you have to retry. Key point is that we're cloud-based and Blackbaud's cloud-based. And whenever you're processing an error, you're wasting CPU. You're paying for CPU that's literally saying, I didn't do it and I'm not going to do it again for X amount of time. So that's something that you don't want to do. We don't want to waste CPU. We pay in the cloud for all of our CPU usage. So why waste it? So key point to that is that this technique is also more efficient and therefore costs less on both sides. Coming back to our solution, with the authentication timer, this is a really simple solution. The authentication timer runs every 20 minutes, and all the clients that are authorized to use that inside our system use that authentication token. So they never run into an authentication challenge. And if they never run into it, they'll never have to process the error, and they'll always be able to communicate. Now, on the rate limits, that's something that we try to match, and I'm going to show you how we do it in a minute, how we match on the outbound side with a queuing system. So the client makes the call. There's a gateway. They don't make the call directly to the Sky API. They make a call through a gateway. The gateway manages the number of outgoing threads, and all the threads that are waiting are sleeping/task waiting threads. So we're not wasting CPU, we're waiting for something to complete. That means that the process that hosts it can go on and do something else while it's waiting. The gateway manages all those tasks and keeps the rate limit to just about exactly what Blackbaud promises us. And I say just about exactly, in the partner channel for customers, we get 8 calls a second. And if you oversubscribe to it, we can get almost all the way up to 10 calls a second. But if we go over that, then we start getting a lot of rejections. So we run between 7 and 10, depending on what the query length is and how long the queries are running. If a query is outstanding for 2 minutes, for example, that's going to use up a lot of rate on the Blackbaud side, where on our side, it's just going to be waiting. So it's a little bit of a balancing error, or a balancing game. But anyway, we match the rate limit. So we match it and we hold clients on our side. We make queries and retries and deferrals on the gateway. So our data collection clients never see any of that stuff. They just see a steady stream of data coming in. Now, all of our calls on the inside part of our gateway are individually authorized. So our gateway has its own authorization system. And when a call comes in from a process, that process must be allowed to make that call before it can go out and collect data. So that's some internal infrastructure that pretty much uses basic OAuth, and I'll show you how that works in a minute too. And then also on our side, all of our calls are logged. So everything that goes outbound is logged. We don't log the data results, of course, because that would independently represent a data leak. But the data ends up in another location, and the call itself, the call and the statistics for the call are individually logged. So we got a nice little graphic here that shows basically how it works. I'm hoping that the animation is showing up during the presentation. But all of our query clients are sitting here running, and they literally run into our request queue. The request queue has some shared pacing logic, and it uses the shared pacing logic is across all of its servers. So the gateway is actually more than one server. It's a server farm that scales up and down based on demand. It always has at least 2 gateway components in it, but it can have up to 10, depending on the load. The pacing logic is controlled by a semaphore that's hosted inside Redis. So we have a counting semaphore that's hosted inside Redis, and when a call goes out, it decrements the semaphore, and when a call comes back, it increments the semaphore. And it's a pretty straightforward version of keeping track of how many accounts we have on a per customer, per application basis. And we get some nice throughput that way. And then, of course, we have the Sky refresh token runs up in the corner up there, and it literally just runs every 20 minutes and keeps everything fresh. So now I'm going to do a quick demo. So you should be seeing my workspace screen. The tool I'm going to use for the demo is an internal tool, but it should show you what's going on. And first thing we have to do is authenticate. And we're going to authenticate to, and if you're familiar with what Azure looks like when you authenticate, this is Azure authentication. And that's also something that's kind of key to how our customers work, is that authentication on our side, we don't provide a username and password database. You must, our customers, and even internally, must use a federated authentication engine. Azure, Shibboleth, ADFS, let's see, request denied. What was that? See, I just tested this demo and it worked. So let's see. Let's do this again. That's 19, right? There we go. Apparently I can't type on my phone while I talk. But our customers provide for us their own authentication engine. And that's also in line with how we do not provide a secondary surface for other people to penetrate the data. Everything that we use on our platform is authenticated against our customers' systems. So the surface area that someone could represent a threat from is basically their authentication engine. And if we were to look, we see that this is an OAuth token, and this is just a diagnostic screen, by the way, to show you that we actually are using OAuth tokens, and we get all these API access selectors. Those tell us what we have access to. So that's our authentication engine. But we're going to go into Sky API query, and we're going to use the gateway to make a call. Now, again, the tool you're looking at here is a diagnostic tool our developers use. But it's an excellent example of what we can do. We're going to go, and first thing we're going to do is just take the first record from constituents, and we're going to do that because we want to know how many records we have. We have 211,588 records. Now, if you were synchronizing to a database, you would take that once a month or once a week, you take a full sync. But when you're doing it every night, we have to do it every night. So if we're going to get all those pages, and we're going to get them in lots of 5,000, we're going to watch what's going on here. And it's not going to take too long. I picked this one particularly. You're going to see a bunch of status numbers up here. The R stands for the overall time. Q stands for the time in query. J stands for the JSON time. And A is arithmetic. So if we're going to look at what the query engine is doing right here, it's going out to get data, and it's doing it the way you normally would. The way you would run through, and let's say you wrote a Power BI connector, and it goes out and says, bring me in all the constituents. It's going to serially go through all the constituents and bring them in. And in this case, it should take, I don't know, about 2 minutes, I think, to come in. So if we had background music, we could do that, or we could answer questions for the moment. But it's actually going to run through it in just about a minute. Excuse me. This problem manifests itself, to some extent it's unique to us, but anybody who needs to move a whole lot of data through the Sky API is going to have this type of a problem. And let's see. Come on, timing through it. I had patter that I was supposed to talk through for this, but I've already talked my way through that patter. So now you're gonna have to wait and see the clock go. Let's see if there are any questions in here while we're doing that. Nope.
Any questions? I saw some moral support for when you authentication denied error.
Right. Yes. So that's live demos being what they are, right? And we're about let's see, we're about halfway through. We're at 135,000 records, 140,000 records, and it's moving on at a good pace. And yes, Paul, the obviously intuitive kaboom button, right? That's this is a developer tool, so there's some other things in there as well. And so first in, first out in the queue, actually that's not true. We parallelize the queue completely. And we actually have the ability, and there's some buttons up here too that can make it happen, to make priority requests. So the queue has, let's just say that the queue has an exact rate match. It doesn't, it calculates the rate match. But if the queue has an exact rate match of 8, and you have a customer who comes up and says, hey, we need to do a demand report right now, there is a way for you to go and say, I want 2 channels right now. And when you get those 2 channels, you'll get those and you'll hold those until you're done with your report. You can also take those channels and release them immediately, and they'll go back into the funnel. So you have a shared pool of however many requests going out, and that's across the entire server farm. And this is almost done, and let's see. So it has 195 meg of data, and the Kaboom person should also note we have wonderful prompts in here for demos. I'm going to let this load, because this is going to load into the UI here so you can see what it is. But that was 2 minutes and 43 seconds, and the query time was 2 minutes and 7 seconds. All the rest of it is JSON and string manipulation. So it's going to take just a minute to load this up because the text editor is going to do lots of JSON formatting, but this is not part of the query format itself. And then in a minute, I'm going to go and activate the gateway, and we'll see what we get through the gateway. Because what you just saw was direct query, just like Power BI does, just like most people use the Sky API connector for. Okay, come on, let's see. And this is all string JSON manipulation right now, trying to build a nice text display. We won't do that the second time. We'll export the data. There we go. So there's a nice delay. So that took 1 minute and 31 seconds to actually format the display, because it's 195 meg. Now what I'm going to do is I'm going to go up here and click this obviously intuitive little turbo button. And what this is going to do is this is going to take all of those queries and run them through the gateway. It's going to do the exact same query pattern, but it's going to run it through the gateway. And we'll call out a few things that are going to be different. You'll notice that in this case, the real time ends up being less than the query time because there are more things happening. That means we get to do more querying. Now, the query time itself is actually higher because there's a little bit of overhead in putting things through this type of a process. The thread management process, the queuing process, there's a little bit of overhead for that. But the benefit at the end is that it runs a lot faster. So we're going to see where it takes it. This time it's running, you'll notice here we've got 37 seconds of real time, but 2 minutes and 26 seconds of query time. That's because each of those threads has their own query. So the authorization question while this query runs, we maintain the tokening system on the back end. You still have to log in with your Sky API, but there is an OAuth flow that allows you to persist the token, Stephen. And if you persist the token, and in our case, we persisted in Redis, then the token can be reused. So once you're logged in once, as long as you keep that token alive, you can continue to reuse it for forever. And I say forever, usually the boundary for that is some big blackbaud 8 Sky API maintenance window. And during the maintenance window, that's when you may or may not lose access and have to re-authenticate. We've had some customers that have been running for a year on the same initial token. And let's see, now we're running to, we should be getting pretty close. And I say we're getting pretty close because the JSON time is creeping up and the query time has stopped. So we ran 7 minutes and 40 seconds of query time, and the real time on it was about 1 minute and 48 seconds. And we're not going to load it this time, but I am going to save it to the desktop. And then we can go back in and look at it here. So it does look exactly like just what we talked about. It's all 211,000 records. And if we looked at the query time, well, that loads. It took 1 minute and 48 seconds instead of 3 minutes. So that's half the time. That's pretty impressive, right? But that's a really small query. So if we were to go back to, close this for a minute. If we were to go back and take another look right here, let's go to transaction distributions. And we're going to get our first record here. And again, this is just our first record. We see that there's 669,152 available transaction distributions. That's going to take a while. So if I have to load them, does anybody want to guess how long it would take? Well, we don't have a guess queue, but it's going to be a little over an hour if we just wanted to use the Power BI way of doing it. And if I go back to my slide deck here, let's bring my slides up. What it actually takes is 9 minutes and 34 seconds. It runs 46 minutes of query time, but you get it all back in 9 minutes and 34 seconds. That's a dramatic improvement in throughput. And it's also 9 minutes and 34 seconds with no exceptions on either side. So with no exceptions on either side means I didn't waste any CPU on my side, and I didn't waste any Blackbaud resources on their side. So it's an improvement in both places. That's another point to mention here, is that it's not just beneficial for us. The process that runs and minimizes errors, matches the rate side, is beneficial on both sides. On the Blackbaud side, they don't have to ever enforce the rate. Therefore, they don't ever have anything that generates an error on their side or generates an exception management that shuts things down across their farm. So we're running nice and fast. And on our side, we don't have any exceptions. So we don't have any wasted CPU processing. There we go. I probably went too fast, but that got me through with enough time for some questions. I don't know if there are any other questions or if anybody wants to see any more nifty demo tools. But I'm going to call that one, that's what we did and how we did it.
So Robert, there's a question from Stephen in the chat, or I don't know if it's a question as much of a statement, but when authorized to Skype API in the past, I've had to manually log in with Blackbaud ID. How did you work around that? It's been a pain point for them.
So I think I already answered that one when I was talking, but just to summarize.
And Stephen says you have.
Yeah, there's an OAuth flow that allows you to persist the refresh token. You have to manage that refresh token yourself, but you just authenticate once. So
you still have to use the Blackbaud ID to log in. You're not getting
you have to use the Blackbaud ID to log in at least once. Yes.
Yes.
And there's
Ben Long is here.
Yes.
We're in good hands now.
And Ben, that's exactly how we do it. We persist that token in Redis, and all of our systems have access to that. But in our model here, our client applications have no access to the tokens. Only the gateway has access to the token. So the client authenticates against the gateway for a particular customer of ours, which we term tenants. And when the tenant is validated against that client, they're allowed to look up the token on the gateway side, and it moves forward. So if you're familiar with the back end for front end style model of coding, that's what we're using. All right. Then I'm going to call that done early, I guess.
Great, Paul. Thank you for
see the nifty diagram again, right? There we go.